One of the issues with a substitution cipher is that the same letter always becomes the same letter, and that might sound dumb, but the reason it matters is there are certain patterns in languages. So like if we look at letter frequency in languages, like in English, we can see here the most common letter is E. Let's enlarge this so you can see what I'm actually looking at. The most common letter is E, the second most common letter is T, then A, O, etc. So if we have a chunk of encrypted text, and if we know that the same letter always becomes the same letter no matter what that is, if we count and we see a whole bunch of, I don't know, the letter J, then it's probably E. The next most common is probably T, then probably A, etc. So that's one thing that we can look at. Another thing that we can look at too is hunting for any words that are by themselves. So we know that like in English there's only two words that are a single letter long, right? The letter A and the letter I can both be their own word. So when we're looking at an encrypted message, this one here doesn't happen to have any, but if it did, we could look and we could say, hey, that single letter by itself is probably an A or probably an I. Now of course that assumes that the message has spaces in it, but a lot of people will use spaces the way they regularly are because it's easier. There are other words though too. If there are spaces in there that are based on the same place ours are in English, if you see the letter E at the end of a three-letter word and whatever the other letter is there's a lot of in the passage, then that's probably the letter V, which means you also know what H is, and you can start to decrypt, you can start to figure out what it is. So let's actually try that. First, let's make some cipher text. So I'm going to go to Project Gutenberg, and I'm going to, this is not what I clicked on. Why Yahoo? I'm going to go to Project Gutenberg, and we're going to find a book. Let's do book categories. Book categories. Fiction. Adventure. What do we want to do? The Man in the Iron Mask is related to cryptography a decent amount, so let's actually do that. So read this book. Three Musketeers. Okay. Alright, so let's go ahead and we'll grab 2 paragraphs. Alright, I'm going to go ahead and paste that up here just to switch it to plain text so there's nothing weird in there. Alright, so we'll paste that in, and I'll press enter. And what should the key be? I want it to be fair, so I'm just going to like input some random text, and I'm not going to look at it. I'm going to block it so you can't see it, so that way we can kind of figure it out together without either of us cheating, hopefully. And now let's make a new program. So new Python file, breaking substitution. Alright, so we have this down here. I'm going to copy that. I'm going to do breaking a substitution cipher, and we have our encrypted message, which equals all that. Alright, and now how to break it. So I'm going to use a dictionary, which we haven't talked about yet, but they're similar to lists and tuples, except they can store variables or other types of data a list or a tuple can't. They can actually even store dictionaries. You can put a dictionary inside of a dictionary. So we're going to store variables in this dictionary. We're going to call this actually stored letters, and we're going to use this to count the frequency that the different characters are used in the encrypted message. So dictionaries are defined by curly braces in Python. So now what we want to do is we're going to say for char in encrypted message, if the character, if the char is not in stored letters, Then we're going to put it in stored letters. Stored letters char is going to equal 1. So what this is going to do is if the letter, as it's going through this encrypted message, if that letter is not already in stored letters, it's going to put it inside of stored letters with a value of 1. However, if it is actually already in stored letters, it's going to increase the value of that character in there by 1. And then let's have it print stored letters. Alright, let's see what happens. Oh, it helps if we do the right one. Run breaking substitution. If char not in stored letters. What did I do? Oh. Sorry. Alright, so there we go. So we can see the frequency of the letters in there. It's a little annoying that they're not sorted in any sort of order, and not only that, but if we run it again, they're not even consistent in the way that they print. So A, V, N, if we run it again, U, N, Z. And there are ways to sort it, but there's kind of a lot of extra stuff to it that's kind of annoying, and I don't want to get into that right now. But I will go ahead and copy this, and I guess I'll just open Notes, and I'll put it in Notes so we can kind of see what they all are. Let's make this larger so you guys can see it too. Hey, can I not make this larger? There we go. Alright, let's make this so we can kind of see it. I'm going to go ahead and put soft wrap on here so we can see the whole thing. I'm looking for any letters that are by themselves, and I think I see one right here. Yeah, so D. It looks like D is by itself. So D is probably the letter A. It could be the letter I. But being that this is written, I think, in third person, not first person, I'm going to assume it's A. Otherwise, I might assume I. So we can go ahead and get rid of printed stored letters since I have that data here. And now I'm going to do print, I'm going to do attempt. And attempt is going to equal encrypted message dot replace. And we're just going to use the replace method because I think that's easier for right now. We've used the replace method before, so it shouldn't be new to you. D is going to become A. Now that might be a little confusing because then it's like which ones are the new A's and which ones are the old A's, especially when we have like letters in here already that were the previous one. So I'm going to use the Ascii color codes. I'm pretty sure it works in PyCharm. I'm going to use an obvious one. I'm going to use, I think, red. So I'm going to replace this with /033 brackets, and red is 31, so 31M. And then we have to close it out with that just to make sure that the rest doesn't become red. So /033 brackets 0M. I think that should work. I think we got that right. So let's try it and see what happens. Oh, not quite. Do I need a space? Do I have to have a space? I don't want a space. Oh. Wrong bracket. Wrong bracket. Try again. There we go. So now the A's are the new A's, and we can use soft wraps, and we can see where all the A's have been replaced. And I'll go ahead and close that. And now what is probably the letter E? So there's 160 I's, 267 spaces, space, so we'll leave that alone. So E is probably the letter I. So let's try replacing that. So attempt is now going to be attempt.replace. So it's modifying the previous one. It's not starting over from scratch. What do we say? I? Yeah, I was 160. So I is going to become most likely the letter E. And if we run it, now we've got some E's in there. use soft wraps. And you know what? I see R-N-E right here. I wonder if that's the word the. I bet it is. Here it is again. Here it is again. I bet that's the. So if we look at R, there's 117 R's. That's quite a bit. Is that the second most common? I think it is. So R becomes T, which means that the N is probably H. So N becomes H, and let's see how this is starting to look. Can we see any others? What did I do? What did I mess up? Oh, I'm sorry. Right there, that one. Alright, yeah, we've got the word the there. Looks right for now. It's interesting. KT, KT, KT. There's a lot of KTs. Common words that are 2 letters long are like is and as and on, if, he, stuff like that. What was our letter frequency? Okay, so A is really high up. A and O are both really high up. So third and fourth. Let's see. So if we had R was 117. Let's go ahead and cross out the ones that we've already done. Can I strike through? I can't strike through? I guess I'll just have to italicize. So that one we've done. Or maybe we bold it. Or maybe we bold and italicize it. We've done that one. We've done that one. You know, I think I'll move them too. So this will come down here because we've done it already. This will come down there. We've done that one already. We've done this one already. So D is really high up with 101. Where is K? K is 94. That's pretty high up. Alright, well, you know what? Let's just stick with what the frequency says for right now, and we can change it later if we need to. A is more common than O, supposedly, and we've got a pretty good length. So we'll assume that D is A. So D becomes A, and let's go ahead and try running that. I'm not really seeing any giveaways here, are you? Let's make this a little bit bigger. Let's try, it said O was the next one, and the next highest is K, so we just replaced D. So we've replaced D with A, and if we look, let's see what's probably the next most common. O-I-N. So we already have I think. No, we don't. Do we have O? Do we have N? We don't. Okay, so what's the next most common after D? Q is pretty common. And P is really common. And K is really common. And A and G, these are all actually pretty common here, aren't they? Okay, so if we go back to letter frequency, we have O-I-N. So let's assume that maybe P is O. And it may or may not be. A lot of these are trying to get pretty close together, so P could be O, A could be O, G could be O, K could be O. Actually, maybe we should assume it's K, actually, since that's higher up. And so it's technically more likely. Alright. Something, that could be fourth, but that's assuming that F actually is F. T could be F as well. But would you start with of, or would you start with on? What's more likely? Let's try replacing, ooh, that could be at as well. Let's try replacing this with on. So G becomes N, On the something something of, I'm going to guess this is of, the month of something, so I bet that's an M. So we're going to say that T is F. And I promise I don't know, I'm just making educated guesses. I'm going to assume that that's a month. So we'll say that F is M. Oh, we've run into a little bit of a problem. So remember how when we were doing our Caesar cipher, and we started running into where we're replacing the same letter with the letter? Well, we just did that. Let's make these capitals, which is going to make it a little bit harder to read, but it is what it is. So if we play it again, on the, I wonder if that's first, on the first something of the month of something, the something, town? I think it's town. And that would match where I thought I saw was. I bet this is was. I bet that's an S. So let's try Q becomes S, and W becomes, oops, V becomes W. Still matches on the first month, on the first something of the month of Monday. Oh, I bet that's Monday. So O becomes D. And X becomes Y. A becomes I. P becomes R. So I think we're getting pretty close. April. I'm surprised I didn't catch that earlier. E becomes L. On the first Monday of the month of April, the market town of something market town of something in something, the something of something of the rose was to in perfect a state of resolution, probably. So J is, I guess, C. I would think C would be more common than that, but that's okay. No, that can't be resolution, because we already have S. I'm not sure what that is. As if the something had something made a, yeah, second. Many citizens seeing. So Y becomes G. Fall, fell. We already have A. Do we haven't? We do have uncertain. Oh, and full of. Ah, uncertain. Got it, got it. So S becomes U. To be in as perfect a state of. So H must be, the rose was born. Yeah, there we go. So H must be B. U must be V. Oh, revolution. Okay. I am not sure what's going on there. Something broke. I'm guessing there was an apostrophe or something there. Alright, well, I'm not sure what B is, but it's not very common whatever it is. Here not had. Just made? Just made? B is J? Jolly Miller? Yeah, there we go, okay. So B is J. Obviously Z actually did end up being Z, although that makes sense because if you remember right, a lot of times stuff towards the end was itself. So Z is Z, and we may not have all the characters here, but we certainly have a lot of them. Look at that. Cracked that in about 20 minutes, didn't I? So not too bad. So obviously, even if you completely randomize the order of your substitution cipher, it's still not too hard to break. And I still did this fairly manually. I just used a computer to speed things up a little bit. Now I got lucky because I didn't have any where I accidentally used the wrong one. It actually matched very well with the frequency analysis, but and a little bit of deductive reasoning for short words. But yeah, even if you run into a few issues, you should still be able to do it fairly quickly.